Yo, what's good, hype beasts? Today, we're going to talk about solving polynomials. I know what you're thinking. Mr. Barton, that's me. That's me right there. Oh my gosh, of course. It doesn't work, but it's me right there. Dreaming in class about being the drippiest mother trucker ever. I know, kids, I know. But you got to wake up. The dream. We're learning solving polynomials. All right. Let's go talk about solving polynomials before you guys get too caught up in being that drippy. All right. So we talked about factoring. Yeah, we've talked about factoring for sure. We have talked about factoring. We've talked about dividing polynomials. We've talked about multiplying polynomials. We've talked about adding and subtracting them. Now we have to talk about solving them. And you're going to say, or what have I been doing this whole time? Solving has a very specific meaning when it comes to polynomials. What we're looking for are the zeros of the polynomial. So if you graph a polynomial, any polynomial in the whole wide world, it's going to look something like this. Right? Okay, not everyone will look like this, but there'll be just these big old wiggly lines, right? Just totally random, nonsensical. The zeros are what we're after. We're trying to find that spot, that spot, that spot, and that spot. If we can find these x values, then that means we have solved the polynomial. So, zeros are where the graph of the polynomial crosses the x-axis. So, what we're looking for basically are x-intercepts. And if we find those, it's solved. Okay, so now you know what our goal is. You're going to say, Barton, can I just graph them like with Desmos and look at a picture and then click on the graph and it'll tell me where these points are? You might be onto something there. But I'm going to show you how to do it by hand because, you know, coconuts and islands and cannibals and whatnot. So here's what we're going to do. We are going to, step one, factor the polynomials. If they're already factored, great. Step two, set the factors equal to 0. Step 3, solve for x. If we can do those three things, we have solved the polynomial. Write these down right now. Write those down. Done? You should pause the video. Write them down. I'm going to erase them. Okay. So if we look at this very first polynomial here, this doesn't look like a polynomial. This looks like a polynomial, but this doesn't. That's because they've done the factoring step for you and it's ready to go. So a factor is each set of parentheses. So all we have to do is set these equal to 0 and solve for x. So right here, x squared minus 9 equals 0. Add 9 to both sides. These cancel. X squared equals 9. Now we're going to take a square root on both sides so that we can cancel the squared. X equals, I don't know if we've talked about in this class yet, but whenever you are doing a square root to cancel an exponent, like you wrote it there, you chose to put it there, you're going to have to do plus and minus on the front. The square root of 9, think about it. Let it simmer. 3. This is the answer we get from this. This tells us 2 zeros. This is actually 2 answers. This is x equals 3 and x equals negative 3. So if we look at a graph at 1, 2, 3, the graph will cross the x-axis right there. And at negative 1, 2, 3 right there, the graph will cross the x-axis right there. These are 2 of our zeros. Okay, let's go find the rest of them. We're going to set this equal to 0. X squared plus 16 equals 0. Subtract the 16 to the other side. X squared equals negative 16. Now we take a square root, and oh no. This is fine. X equals plus or minus, but the square root of negative 16. We're in deep doo-doo here. One of the 2 rules in math that you can't break is taking square roots of negatives. Because you're taking a square root of a negative here, you can't do it yet. We haven't talked about it. So this one has no real solutions. Just this part. These are still solutions. These are still answers, and we can't ignore these. But this chunk here doesn't have any real solutions. Okay. Now we look at this last one. Be brave, children. We're going to face one of your 3 greatest fears. Subtract 5 on both sides. 2x equals negative 5. Divide by dose. X equals negative 5 over 2. A fraction. Mr. Barton, my 3 greatest fears in life are commitment, not being the drippiest, and fractions. I know. Unfortunately, it takes commitment to be the drippiest and to solve fractions. So you're going to have to face a lot of fears. So these are our answers. Our answers are x equals 3, x equals negative 3, and x equals negative 5 over 2. Your homework might ask you to turn this into a decimal, in which case x equals negative 2.5. But you can use the calculator to do that part. All right. Let's look at example B here. You're going to say, Mr. Barton. Oh, no. There's actually a step 0 we should talk about. Get the polynomial equal to 0. So you have to check that it equals 0 first. If it doesn't, you have to move everything to one side. It's pretty easy. I think you can handle it. I don't know that there's any examples. That's an issue. It doesn't look like it. Okay. So on this one, step 1 is factor. So we're going to have to use everything we learned in factoring unit. Okay. Remember when I told you that if you can't factor, you're probably going to fail this class? Oh my gosh, it's almost like you need to factor. You need to know how to factor. And you didn't do any of your homework and you got an F on the factoring test? Oh, poor little baby. Maybe you should have listened to your math teacher and learned to factor. So let's factor. We're going to divide out our GCF here. There's an X in all of these. And 4 goes into 8, 4, and 12. All right, so let's divide everything by 4x. But this leading one's negative. I don't really like negatives in front. My 3 greatest fears are not being a famous YouTuber, dying in a car accident, and having a leading coefficient that's negative. So we're going to divide by negative 4x. Okay, so we have negative 4x out in front. Negative 4 goes into negative 8 2 times. We had 3 x's, we took one out, x squared. Negative 4 goes into negative 4 positive 1 times. We had 2 x's, we took one out, so there's 1 left. 12 divided by negative 4 is negative 3. The x goes away, equals 0. Now we're going to try and factor this. There's a number in front of the x squared, so we're going to have to do complex factoring. So we're going to multiply the 2 to the negative 3. So we're going to have x squared plus x minus 6. The factors of negative 6 are 1 and 6, 2 and 3. We can make a positive 1 with a positive 3 and a negative 2. And 3 times negative 2 is negative 6, so we're good. So this is going to factor to x minus 2 and x plus 3. Now we have to divide by that original coefficient. So we're going to divide by 2, divide by 2. 2 goes into 2 one time, so this is x minus 1. 2 doesn't go into 3, so we put it in front of the x. So we have 2x plus 3. still equals 0. Still with our GCF of negative 4x out in front because it's our little brother and we can't forget it. Otherwise, our moms are going to be mad. So now that it's factored, that's the hard part. Now we get to do the easy part. We set all the factors equal to 0 and solve for x. So negative 4x equals 0. Divide by negative 4. These cancel. X equals 0 things cut into 4 pieces is still 0 things. X equals 0 is one of our answers. X minus 1 equals 0. Add 1 over. X equals 1. That's one of our answers. 2x plus 3 equals 0. Subtract 3. These cancel. 2x equals negative 3. Divide by 2. The 2's cancel. X equals negative 3 over 2. A fraction. But oh well, you're good. You're fine. Breathe, kid. These are your 3 answers. You might want to turn this into a decimal, maybe. X equals negative 1.5. But your calculator can do that. All right, let's do a few more examples just to make sure that you got the idea. All right, here. This one looks complicated. There's no GCF, right? There's not an X in everything. The only factors of 9 are 1 and 9, 3 and 3. The only factors of 25 are 1 and 25, 5 and 5. There's nothing in common. So for this thing, we need to do complex factoring again. So we're going to multiply the 9 to the 25. And we're going to talk very slowly so that your math teacher has time to multiply that in a calculator so he doesn't goof it up. So we have x to the 4th plus 224x squared minus 225 equals 0. Oh, I could have done that. I'm a genius. Now we have to factor this. And you're like, Barton, those are big numbers. Don't worry. They pick the easy ones. So 225 has factors of 1 times 225. Oh, look, we can make a 224 with those. 225 minus 1. So we're going to pick negative 1 there. So this is going to factor to x squared, because that's the thing in the middle, minus 1, and x squared plus 225 equals 0. This is a difference of squares, right? This is squared, this is 1 squared. So we can factor this to x plus 1 and x minus 1. And then this will stay the same. X squared plus 225 equals 0. Now we set our factors equal to 0. So x plus 1 equals 0. Subtract 1. X equals negative 1. That's one of our answers. X minus 1 equals 0. Add 1 to both sides. X equals 1. X squared plus 225 equals 0. Subtract 225 from both sides. X squared equals negative 225. Take a square root and stop right there. You can't take a square root of a negative. So these are our 2 answers. Wonderful. All right. For this one, it's already factored. This is a factor, this is a factor, this is a factor, this is a factor. So now we just set them all equal to 0. Negative x equals 0. Divide by negative 1, because that's what that invisible coefficient is. X equals 0. X minus 10 equals 0. Add 10 to both sides. X equals 10. X plus 1 equals 0. Subtract 1. X equals negative 1. 2x plus 3 equals 0. Subtract 3. 2x equals negative 3. divide by 2. X equals negative 3 over 2, which is negative 1.5. These are your 4 answers. And you're done. All right, let's see. What is this thing? Oh, is that our last one? It is our last one. All right, be brave, children. Be so brave. We gotta factor this. All right, let's look at it. How are we gonna factor this? All right, let's go ahead and take out. Well, there's 4 terms. 1, 2, 3, 4. It's GCF factoring. Or not GCF, pardon me, grouping. So we're going to take out the GCF here and the GCF here. So we have 2x squared here. So we're going to have 2x squared. 2 goes into 2 one time. We had 3 x's. We took 2 out, so we'll have 1 x left. 2 goes into negative 14, negative 7 times. We took out both x's. Here, let's see, what goes into both of these? Does 16? Does 16? Does 16 go into that? Let me double check. I'm sure you're screaming at your screen. Of course it does. It don't. It doing. All right. So let's take out, does Ocho? I bet Ocho does. Ocho do. All right, let's take out negative Ocho. We already know this isn't going to work, but maybe we don't. Maybe only I do, but we'll see why. Negative 8 goes into negative 56 7 times x. Negative 8 goes into negative 45 times. Oh no, this isn't good. Unfortunately, these don't match. So what are we going to do? Well, there are some things we can do. Let's maybe pull a 2 out first. My pen's all goofed again. All right, 2. So we have x cubed minus 7x squared minus, what's half of that? 28x minus 20 equals 0. Now, unfortunately, this thing looks pretty unfactorable to us. We don't have a way to factor that. So there is a thing called the rational roots theorem. It's a beast. I remember when I was just a wee lad, like you kids, learning the rational roots theorem, and thinking, wow, that's so easy. But you know what else is really easy? Doing 100 push-ups in a day. But do you do that? Heck no, because it's a lot of work. Just because it's not hard, right? Like, sure, it's you couldn't do it all at once, right? But if I was like, I'll give you $1,000 if you film yourself doing 100 push-ups in one day, right? You can time lapse it or whatever. You could do that and you could get $1,000, right? But you need incentive. And if I know one thing about teenagers, it's that getting their homework right is not incentive enough. So you're not going to do it. I'm just being real. Like 3 of you would, and then 26 of you wouldn't. But we have a backup plan. What are the solutions? The solutions are where this graph crosses the x-axis. So do we perhaps have a way that we could just look at a picture of this and go, oh, it's right there, and right there? You bet your butt you do. Desmos. So I've graphed this polynomial. It looks kind of like this. This thing goes down for a long time. This negative, this thing right here, goes down like this. And it just keeps going down. And I swear, this thing just keeps going down forever. Like that. And this right here where it turns around, this is like negative 430 in case you care. But give or take. It's not exactly, I don't think. But that's not what we care about. What we care about are the solutions, which is where it crosses the x-axis, which is here, here, and here. And we just want the x values. That's the answer. X equals negative 2, x equals negative 1, x equals 10. And we're done. Pack it up. Call it a day. We're going home. Tell your mom you lived. That's your notes. I hope you enjoyed them. Make sure you gently press that subscribe button. Click the bell icon so that you get notified every time at about 9 o'clock at night when I upload these videos. You could even watch them the day before they air in class. You could come to class with your notes done because God knows you're not sleeping at 9 o'clock, right? All you're doing is looking at TikTok trying not to be miserable. You could watch your videos and then you show up to class, knock out that homework in like 5 minutes, and then bounce. That'd be tight, huh? All right. If you folks have questions, make sure you ask. If you need help with your homework, make sure you ask for it. If you haven't told your mom you love her yet today, go tell her. All right, I'll see you guys next time.